topic's called Looking Ahead and Keeping Connected, Tech Development for Mobile and Offline, and we have Pierre and Mark who are going to talk about it, and hopefully the Wi-Fi allows us to demonstrate our offline. Boom, boom. There you go.
Okay, thanks everyone. I'm Mark Lynch, as met you all earlier, and I'll introduce Pierre.
Yeah, I'm Pierre, and I'm tech lead for the assessment stack at Learnosity.
So we're going to start off by talking about two key topics, mobile, and that relates to a few core areas, with offline being one of them. So, as we talked about earlier, we're solving the difficult but common problems, and we want to solve it for the real world. We want to make it work everywhere. It's not for a theoretical thing that could work somewhere. I do remember being asked, do I need to talk closer to that? Yeah, sorry, I'll talk closer into that. I remember being asked at one stage, in Australia they're rolling out a national broadband network a few years ago, and we were approached to, could we develop something that would only work on the broadband network when you have, gigabit downloads? And we're like, no, because that's just a waste of everybody's time and effort to build something that won't work in the real world. So when we talk about mobile, there's a couple of key attributes that we need to deal with, and all of these have to work together for it to work well. It's got to be fast enough. Obviously, we've got a lovely laptop here that is super fast, but not everybody has that. And mobile devices have, while still getting better, they have limited CPU. They also have to deal with battery life, and they have to deal with changing connectivity, which is often kind of manifests itself as, can this work offline? Because it's when you're online sometimes, you're offline on the way home from school or to and from, or in the subway. You lose connectivity, but you want to keep working. And then there's challenges with screen size and the fact that there's just multiple platforms to deal with. As I talked about earlier, it's not just the web, it's now iOS and Android as well. And so we've talked about these numbers earlier. So yeah, this is some of these core areas. And I want to just break that down in a little bit more detail and how some of these things, and if we look at these kind of core attributes, breaking down our numbers. So we have, the breakdown we showed earlier. We also have 10 million Windows and 1.7 million Macs, which I was surprised the fact that we've got more tablets than we have Macs running on it. But then that reflects we are skewed a bit to K-12 environment. So when we look at those, if we add up all the Chromebooks and we estimate, I don't have solid figures on this, but I know from sales into laptop sales versus desktop sales, we can kind of estimate that, let's say conservatively, 50% of the Windows machines are going to be laptops in the environments we're seeing. And so if we combine that, that gets us, of our 24 million users, about 75% are basically portable. That's a combination of mobile, but also a combination of devices that move around, that have batteries, that have potentially limited CPU. So, yeah, 75% of our customers have these problems every day, whether they're using it on mobile, like on an actual phone is what we traditionally think of mobile as tablet, but every single laptop, every single person in this room on a laptop going, oh yeah, is my battery going to last? Am I going to get to the end of the day? And the approach we take is you can't have any learning if you don't have any power. So we want to make sure that we're helping to deal with that. So I've got a slightly expanded definition of mobile in a lot of cases, but mostly because solving for the bigger need, but we're also solving the exact same problems. And everything that we do to run faster on a phone or a tablet makes it go faster on Chrome, and vice versa. So we're not just solving, it's not this afterthought of, well, yeah, the 10% who are actually using tablet or phone. It's the 75% who have the same issues. This is probably the only thing that's not mobile in my world. It's the chained to the desk computers. And so when I see, I teach robotics at my son's school, and I go in there and it's at the end of the day and everyone's coming in and their laptops are kind of running out of battery power. It's like, where can you plug it in? And in kind of school and college environments, and actually even corporates, there just isn't place to plug everything in. There's certainly not 30 power sockets in any classrooms. So the common and difficult problems, all of these ones in the middle are really common, and they're kind of already solved. So larger screens, changing connectivity, we have solutions around that. Performance, touch input, all of these things just work. Then the smaller screens, that's solved, but it does require designing for smaller screens rather than if you build huge content, it's not going to work on small screens. And then Android and iOS, they're totally solvable too. So one of the most common questions I get when people are asking about mobile is, native versus HTML5. And it's the, I suppose, held view, or people come to go, but native's always faster. And they'll often quote this at me. Something like Mark Zuckerberg came out with, the biggest mistake we ever made is betting on HTML5 over native. That was back in 2012. And as part of this presentation, I had a look at it. It never sat right with me. I was always like, we have it working just fine. Maybe for Facebook, it wasn't quite fast enough, but it works really fine, really usably all the way along. But I dug into the quote. And it wasn't that he hated it. It just wasn't there at the time for Facebook and with all the devices. It's not as bad. He was really excited about it long term. And this is part of some of the context of why. So back when Mark Zuckerberg made that quote, it was 2012. And so they've probably been working on this for a year or 2 years before that. So you're dealing with devices a couple of years before that. In the meantime, this is the iPhone and Galaxy, every single phone that's been released, and the pass mark score, so basically how fast they are. And you can see how steeply that is going up. So that's relative to an iPhone 1. I think we set that up as. But basically, every year, every 2 years, this is going so much faster. So even if you're on a 2-year-old phone, you're twice as fast as, or at least twice as fast as when Mark Zuckerberg was talking about that not being fast enough. It just keeps getting faster. I'll hand over to Pierre here.
So if we look at where we are at today, we have on the left here all the native development issues. So the performance, it's really the fastest. I think there is no really arguments about that. But you get trade-offs. The development speed is much slower. If you target 3 platforms, so native, Android, and also the web, you might need to do things 3 times, and it will take much longer. It will cost you more because you need to have devs that know the 3 languages. You need to have very skilled people to do that. And to maintain all these 3 platforms, it will cost you also a lot of money. And you can't have this approach of write it once and it works everywhere. On the other side, we have the mobile web. So mobile web is an HTML page that works fine on a desktop browser, but also fine on the Android and iOS browser. So it's still pretty fast, especially these days. But the development cost, the maintenance, and the write once and work everywhere is really good there because we deliver things quickly and it works fine everywhere. In between, we have something called hybrid, and what we call hybrid is basically a web view that you render in a iOS or Android wrapper. So you can use most of what you've done here and also make it feel a bit more native. And that's the approach that we've taken with our offline offering. So for that, you still need to know HTML, JavaScript, and CSS, but on top of that, you will have to use a little bit of Android SDK and iOS. And something that's really exciting as well about HTML5 these days is that Facebook and other companies are really pushing hard to make the web offering as much performant as the native ones. And the new React version that Facebook released a few weeks ago, mentioned a few weeks ago, they are not released yet, is really promising near native performance. So it's kind of making us feel great about it because it shows that the web is still the right bet. Another issue that you have when you develop mobile and offline is mostly responsiveness. You want to make your app look great on multiple devices with a different screen size. So if we look at one of our demos here, we can see that on the desktop it looks great, it takes the full width, but on mobile, if you were to render exactly the same thing than that, it would look horribly shrinked, and yeah, it wouldn't be usable at all. So you need to get a responsive approach where your app is adapting to the size of the device, but also your content adapts to the size of the device. So here we have a two-column approach on the left, and here these two columns, they wrap each other. The question goes on top of the second one.
I think a key part of that is that Learnosity item automatically will do that. You just have to not break it by making your site stay out to the full width. So we make it easy to make it responsive. Yeah.
So we have our assessment player has an approach that instead of relying on the media queries, it has some breakpoints that are relative to the wrapper. So it means that if you have stuff on the right and left of the player, it adapts to that and will render the content in a good way. Also, something you will need to deal with if you target multiple devices with a web is maybe use some assets that make it look more native to an environment. So if you develop mostly for an iOS, you might use some style sheets that make some elements feel more iOS-ish, and for Google, more material design. And that's what you can do here in a few lines of CSS. That's our MCQ block, how we do it, and probably like 10 to 20 lines of CSS, you can get it to render quite differently.
So yeah, I mentioned earlier, offline often comes as, the question of, can you do offline? It's because, in nearly every scenario, it's because sometimes you're online, but sometimes you're offline. So it's about the changing of connectivity. And why do we want to do it? So that it can be really reliable. If it's on a flaky network, it will continue to work. As I said, subway, you go into the subway, you want to keep doing what you were doing. You don't want to stop just because of that. The simplicity, it keeps working for people. And product reach, you can deal with, you can kind of reach people with more scenarios or in more areas. This is just a standard Chrome. If you don't do anything in your web app, what you get if you're offline and you click a link. But we've had a long journey on offline. We've been working on a lot of these problems since 2004. So I mentioned earlier on a computing skills test, actually I'm not sure if I called it that, but the key application that we developed. And this was back in Flash heyday, when Flash was cool and it wasn't a bad thing that everyone was trying to kill. And it was the right tool for the job. It allowed us to do a great assessment player, allowed us to scale, do a lot of stuff that just was not possible from an accessibility perspective, but also from a offline perspective. It would load the entire assessment, it would hold it in memory, it would, at the end, if you were offline, it would have a fallback mode where it would save the assessment down to an encrypted file, and then you could email that back. So it came from high stakes assessment, going, well, hang on, if they've spent the kid has spent the time to put the answers in, the worst thing you can do is say, oh, sorry, I lost your exam. So we built a lot of that into it. And then that actually, we finished working on that in 2011 because they canned that entire assessment, and they were talking at the time about putting stuff on to be fully high stakes exam online in 2015, but unfortunately that came and went, and they're still doing every single paper online there, and they got rid of that particular assessment. But we continued to keep working on the challenges and the problems, and we built the Assess API. That is basically a replica of what we've done in Flash, but all in HTML5. And so it does loading everything. When you start an exam, everything's ready to go. And if you finish an exam, it will, and you happen to be offline, it will save all the results and be able to send them back. We also looked at the app cache. This is was some promising technology around dealing with apps offline. And IndexedDB is another technology that came along in the browsers that didn't exist before that, where we needed a database to store some of this. Otherwise, you're storing it in cookies, or there was just nowhere to store any of the results except put it onto maybe do a file download or something like that, but even that is challenging and messy from the browser. So we were continuing to work on this offline piece, and we released actually a version with AppCache in our items API version 125. So, but that's back in 2013 we released that, and we worked with a couple of customers around using it. But unfortunately, it turned out AppCache is a bit of a dog. It just didn't work. It kind of technically did work, but it was too hard. It was really cumbersome to use. So it didn't save any time in implementing offline. It just made it really hard. So we killed that, and then we started working on what we call packaged offline. I'm going to hand over to Pierre to talk about this.
So what is packaged offline? First of all, it's your code, so you're responsible to put everything together. But the important part is that it's also your content delivered in the app and with our APIs too. So that gets delivered in a package, and then it makes a really powerful offline offering. So we support Chrome OS now, and we also have an iOS package that is available for clients to use. And we are working on an Android one. It's going to be released next month, and we're pretty excited about it. But what does it do? First, it syncs your content when you're online. So you open your app, your content gets downloaded, or it can be done before, but you need to be online to do that, obviously. And then once your content is there, the APIs are in your app, so you can use basically most of Learnosity offline, which means that you can save all your responses, you don't need any connectivity, and then when you're back online, you can just push a button and it all syncs with our servers. One of the first questions you might have is, but how do I get my content in the app, in the package? Well, we do that for you. We have a data API job called offline package. So what you do here is that you do a request to data API with the activity that you want to get offline, and we'll get all the items and assets related to that activity. For the ones that have absolute path to some online resources, such as images or MP3s, we scrape all that, we download, we put it all in the package, and then we replace all the absolute path in the questions and in the items content with relative ones to the package. That is an asynchronous job. It takes some time to do, so that's something good to know. Once you get all your content delivered in the app, and that when we gave you also our APIs, that's how the structure of the package looks like. So we have a vendor and then Learnosity. Here we have all the item banks, so activities, assets, and items. And below that we have our APIs that you can use offline. So items API is the main one to have. You can have also questions API, so that's a must-have to have actually, because that's what renders all the questions. And then you can also have the access API, which is the player. So how does it work? First, what you need to do is business as usual. You need to get your security generated. So that's done in your servers. It's not safe to do it in the client because you need your secret, you need your key, and you don't want anyone going in the app and try to find out what they are. So you do that online on your server, and then you call a method that we have called prime offline, and this method will do all the authentication check with our servers. Once the authentication comes back, we save all that in IndexedDB that Mark mentioned before, and then basically you can go off to the jungle and start your activities. You can use Learnosity, it will all work very fine. You can continue, stay a few weeks in the jungle, and then when you're back, you can just push a button and it will all sync to our servers. So once you have done that, you can resume your activities with other devices, or you can, the teacher can also see the reports and etc. So I'm going to show you a demo of our offline package on Chrome OS. So the first page we have here is the login. When I will click on submit on login here, it will do it will get the security package from one of our servers. That's something that you will also need to do. So you can see here on the top right, I have the online icon, which means that I'm online. Okay, fine. Now I can go on my trip to the jungle, so I will put myself offline. You can see I'm offline here, and I will start my new activity. Cool. So I have a few items here rendered, and that's all grabbed from the Chrome app package. So I can play some audio, I can start playing with that. I have the full scoring stuff is there, drag and drop, perfect. And when I'm happy with it, I can either go back and continue this activity later, or I can resume it, do a few changes, and then submit it. You can see at the bottom here that once you submit, your session is ready to be synced. This view here is rendered using the needs pushing method, which will return an array of questions that are available on the device, but not synced yet. So I'm still offline, I can't sync. So when I'm back from my trip, I'm back online. Yeah, and I can push sync. Boom. So here we have the session that has been synchronized to the data API. I can test it, I can get it. Your teacher can also see that in his reports. But it doesn't block me to continue doing other activities. So, oops, I can do that one here. Okay, back. So you see now I have another new one that is not synced. And if I restart this one, which is possible, I have two. And I can sync them again. So that's very simple to do. And as you can see, it's very powerful. So that demo, it's also available on iOS now. We can give this one to you, the Chrome app, but also the iOS one. And if you wait 1 month, you can also get the Android. There are a few challenges, though, with the offline package. The first one is API updates. You won't be able to dynamically get the latest versions because you need to get the API and put it in your app. And also, every time you put the API in your app, you will need to release it to the App Store, etc. So that takes a while. Also, content provisioning. Now, you might just grab your content, include it in your app, and then you release your app on the App Store. So that's a manual thing to do, and that might take some time. If you want to do dynamic content provisioning, you might need to do some work on your backend as well. So your app will talk to a page on your servers, which is a proxy to our jobs, and that you will be the middleman, sort of. Troubleshooting is hard because it's offline. You won't get live analytics or anything like that. And also a challenge that we faced when we developed this Chrome OS app is that there is something called CSP, which stands for Content Security Policy, and all your JavaScript needs to be compliant with that. So it's a few sets of rules on top of what the browsers does that protects you against cross-site scripting. So you can't use functions like eval in JavaScript and some inline scripting and stuff like that. So if you have some existing code that you plan to package offline, you might need to just put some headers on your page and make sure that it's CSP compliant. So that's not an issue with iOS. It doesn't require to use that. But overall, it's a bit more work, but it works great.
Cool. Yeah. So now there's two kind of totally supported solutions. One is a lot of stuff in the Assess API that already allows you to handle a lot of offline cases. And if you've got the use case for packaged offline, where it's worth, there is additional investment in your time and effort to do that. But if you've got a use case for it, it's really totally possible now and works really nicely. But there's also some other things that we've been tracking for a while. Service Worker is a new technology. I'll say new. It came out as a draft in 2014. It made it to, you can see it follows the same pattern as some of the AppCase stuff. This stuff takes time. It comes out as a standard, a draft. It's got to get rolled into the different web browsers. It takes a bit of time. But middle to late 2016, Service Worker became available in some of the browsers, namely Chrome and Firefox. And what it is it allows you to, instead of showing that screen, it allows you to intercept requests there. So you can go on, instead of having to switch or build a whole app, you can do it in the browser. So when you realize you're offline, you can build the same thing we're doing into the packaged app. You can basically do that in a browser without having to do a separate piece, which means you get the benefit of the live updating, fundamentally running online most of the time, but continuing to work offline in the background if you happen to be, you go through the subway, you're on a bus home, it'll just do that. So we've rolled out, or we've done a POC of that. So far, it's looking promising. We're taking a slightly more cautious approach, having been burned once by AppCache. And we're still, kind of following the browser, making sure that it's working in all scenarios and continuing to test. So it's coming. And what?
Something great about service workers is also that it's part of WebKit, so you will have it as well in your hybrid solution, not only in the browser. So you can do offline package with service worker.
Yeah. I think that's the key piece in terms of kind of wrapping up. Anything on mobile, it's all about performance, as in making sure you're doing the right thing, being efficient. I'm going to talk more about that in the next session, so I won't go on to that too much. See, responsive is already solved as a problem. If you're doing design for apps, you know about responsive. We make it as easy as we can for you, and we're always interested in more feedback about it as well, about any aspect of the system. Changing connectivity. That is the key challenge. It's a little bit harder, it's a little bit more effort, but it's completely possible, and it's only going to get simpler. So if you've got a use case now, go for it. If you've got I'd like to solve offline, kind of know that it's coming, and it's going to get even easier over time. So there might be a lazy approach on some of that it's just going to become a solved problem. And I think a key piece is remember that a lot more of your users are mobile than just the phone. So you need to design for that as well. And if you can do the same one piece. From Learnosity perspective, we've worked on a phone since we started doing it. So the iPhone was launched the year we came out. We kind of had the view that at that time we didn't think a lot of people were going to do assessment on phones. It wasn't a primary design piece, but we made sure it worked. We continued to test on tablets the whole way through to make sure everything worked right. And we spent a lot of time in the last 12 months as we saw more and more usage on phone, just optimizing little pieces. So things like making the math formula just fit perfectly on the screen when you load it on a phone. It was a tiny bit off when we looked at it, worked perfectly, but you had to scroll. It's just little polish pieces like that. So that's already working great. And offline's continuing to get easier, and with the goal is offline working well is unnoticeable. It's how Facebook works. It goes offline, and that's some of the reasons why they have built a native app there. Fortunately, they have the budget to do almost anything they want to do. So I don't think anybody in this room has the same budget as Facebook to throw developer resources at it. But we're going to absolutely get there. We're going to keep pushing that so that everyone in this room does have an app that works beautifully offline. Actually, no, there's one more point I was just going to say. I was just talking to somebody upstairs, and I don't know if they're in this room, but they're telling me about a full assessment that was done in higher education, and it was basically entirely given on mobile phones. So I was like, all right, I thought it was mostly kind of kids doing it homework, but it was full assessments, 60 odd questions just on a phone as a primary interface. So it is happening, and it's happening more and more.